Starting with number 12 from the homework. Oh, and 20? Okay. Reflect the following figures according to the given information, then list the coordinates of the pre-image and the coordinates of the transformed image. Okay, so getting the coordinates of the pre-image is not really a geometry task. It comes from middle school or from algebra. 1, 2, 3, 4, 5, 1. So negative 5, 1. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1. Did I count right? Did I get the coordinates right? Hopefully. Now, I'm just going to use my rule. I'm just going to use my rule. I'm not even going to really use the coordinate plane. Remember, I'm not going to use the fact that I'm finding the distance away from the line of reflection and I'm going the opposite. No, we don't do that when our line goes diagonal. That's easy to do when it's horizontal or vertical. I am simply going to use my rule. And the rule says switcheroo, switch places. So I'm just going to switch. 1, negative 5, 5, negative 2, 1, 7. I'm going to plot that in a new color. All right, so 1, 1, 2, 3, 4, 5. That is A prime. 5, 1, 2, 3, 4, 5, 1, 2. B prime. And C is 1. 1, 2, 3, 4, 5, 6, 7. C prime. Connect the dots. Doesn't that look cool? So that is that obtuse triangle. I think it's obtuse, yep. Reflected over the line y equals x. And yes, it's going to overlap. All right, next one. Reflect this over the line y equals 2. Okay, so y equals 2 means it's going to hit my y-axis and it's going to hit it at 2. So I go to my y-axis and I go to 2. And this will be a good opportunity for me to show you the other way to reflect something on the coordinate plane. There's no rule on your list that says, here's how to reflect over the line y equals 2. There's no rule. So instead, you're just going to count. So how far away is B from the line of reflection? 1, 2, 3. So I'm going to go 1, 2, 3 above. I'm going to call it B prime. A is 1, 2, 3, 4, 5, 6, 7. So I'm going to go 7. 1, 2, 3, 4, 5, 6, 7. C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This has got to be so fun just watching this Stanton count. Okay, and D, 1, 2, 3, 4. Oh, it's the same as A. Right next to C. Okay. Best I can do. All right. So that is the figure reflected over. And, all right, so A is negative 4, 9. And that was the one y'all were asking about. The rest were correct on the homework answers. Okay? Pavin's asking if we need to memorize the rules. So, yes, you do need to memorize the rules. Number 14, this is a good problem. This one is not as laborious as the last one. You're not going to sit here and watch me count forever. All right, reflect point L over segment KP. Everyone go to their paper and draw segment KP if you haven't already. You need to picture point L. If I crease my paper and the crease coincides with segment KP, where's L going to land? Think of creasing that figure on KP. If I crease it on KP, L is going to land right there at J. So you're thinking, which other point is equidistant from KP as L is? So L is, kind of this far away from KP. Which other point is that far away? See what I'm saying? So you do need to draw the segment in, okay? 18 says, write the resulting coordinates of the image, given the coordinates of the pre-image and the description. All right, so the pre-image is negative 2, 6. I want to reflect over y equals x, and I want to translate up 10. All right, we'll write the middle step in so we don't get confused. Reflect over y equals x. Well, that just means trade places, switcheroo. Boom. I just reflected over y equals x. Now I'm going to translate it up 10. We know that means y plus 10. So that's how we end up with 6, 8. 19. 0, 9, translated up 2 and left 3. So up 2 changes the 9 into an 11, and left 3 changes the 0 into a negative 3. Then I want to reflect it over the x-axis. Remember, reflect over the x, change the y. So I'm going to change the y. -3